Hello guys, this is another Java video and today we're gonna talk about Kotlin. So I'm gonna show you some of the basics of the language. So let's get started right now. Okay, so I have a project here on my idea. I wanna show you guys. Kotlin was created by JetBrains, so it's the same guys behind IntelliJ IDEA. So we have pretty good support in IDEA. So let's start. This is a Maven project with Kotlin, right? So we will need the Kotlin Maven plugin from JetBrains, right? I'm using Kotlin version 1.3.7.2. This is how you configure it, right? I'm also using Maven jar plugin to generate a jar and surefires to hook JUnit and Kotlin. Then I have my JUnit 5 dependence. I'm using Kotlin standard library. Also, there's a dependence for Kotlin and JUnit. And here, I'm adding a specific Kotlin library called coroutines. So there's a bunch of things here I want to show you, but let's take a look slowly. So here I have a main class where I'm importing the other package and running the other main applications. So I have a bunch of main applications with all other code, right? So I'm gonna run this big one here so you can see that everything is working, and then we can take a look package by package, and I'm gonna show you several parts of the language, all right? So as you can see, it works. Now let's get into the code, all right? So basically here, let's start with, let me see. We can start with functions, all right? So in Kotlin, you're gonna have a KT files. In here, I'm showing lots of different ways how you can deal with functions, right? So I created a main method here. You don't need to receive args, and you can say colon unit, right? Unit means void. I can tell that Kotlin was very inspired by Scala and also Python. So basically, here's a standard function. You need to use the word fun, which is fun. Then the name of the function, and then it's similar to Scala, right? So you have the variable name, colon, and the type. So I'm receiving two integers, returning an integer, and then I return. Semicolons are optional. You can put or not, it's up to you. But if I put it here, it works. It's not a problem, all right? Here I can do a function as well, but I can do it in one line. I don't need to have the curly braces, right? I can do it in one line. Here's another example how to do a function. But here I'm using a string interpolation from Kotlin. This feature is pretty good. So you can see dollar and then you can get a variable, or you can do expressions if you put the brackets here, the curly brackets, and then you can put your expression. Here also I'm calling a function, but here the difference is I'm having default values, and that's a cool feature. So I can say by default A is 0 and B is empty string. So if you don't pass that argument, I'm gonna have default values. Here we have a data class where I have A and B as a string, and here I have a function returning that a data class. And Kotlin has destruction. So as you can see here, I have a class, right, AB, and AB has A and B that are a string. Like Scala, you have val and var. So val is immutable, var is mutable. So there's lots of copies from Scala here. So basically, when I destruction, I can get variable by variable if I want back, right? So I'm getting A and B here, then I can use it. So I don't need to do the class if I don't want it. So that's kind of a destruction. And here we are calling the other functions, and you can see here I'm calling one with default, so I don't need to pass parameters. All right, so that's how you can deal with functions. Now let's take a look in variables. So how we can work with variables in Kotlin. So basically, like I said, val is immutable. If you want to mutate, you use var, right? And also Kotlin can infer the type inference for you. So here x will be 5, and therefore int. Here I'm playing with various syntaxes, like I can do a semicolon int and then the value, or I can just say type inference again here, b equals 2, then it will be int, or I can say c space int as well and defer the value to later on. Here I'm saying that c is 3. I'll work. Here I have like string templates, which I kind of showed before. This is a cool thing I see in Rust as well. You can use underscores, but they're just for reading. So you always know what kind of a number you are dealing with. So this is a credit card number, for instance. And then you get the number purely without the underscore, right? So you can see there's a L here, like in Java, so it's long. And then I'm getting the long number. Here I have multi-line strings with 3 quotes here. And here I can use these pipe characters to perform some margin control. And here I also can do expressions on the multi-line strings. This is also a main, so for instance, I can run this guy directly and you can see it works. All right, so that's variables. Let's take a look in loops, how we deal with loops in Kotlin. So here I have some examples. I have the basic loop where you can use this syntactical sugar list off, similar to Scala. And then I can creating a list of strings. And then on the for, I can just say in. Then you can do a for each. Here I have another loop example where I'm doing list off, but actually I'm going for index. So you just say dot indices, and then I can print the index and I can access the list index, right, with the expression here. Here I'm doing a while, pretty much similar like to Java or C. You can do loop range, so this is similar to Rust as well. So I can say x in 1 to y, and y is 9, and actually will be 10 because I'm plus 1. Here is another example. I want to go from 1 to 5, and then I want to go 6 to 10, but then 6 to 10 I want to go 2 by 2, so it will be 6, 8, 10, and that's what will happen, so I can skip. So here I have a main as well. I'm calling my functions, so I can run the code and you can see it all works. So there's some interesting loops here. We can see similar to Java, this is pretty similar to Rust, for instance. Let's take a look on other things. Some conditionals, which are basic as well. So you can do classical if, no big deal here, if else. You can also do in one line, so you can do like this, if else. You can use when, which is kind of the pattern matcher for Kotlin. Then you can say when is the integer 1 or the string hello, or when the type is long, or when it's not a string, or something else, right? And then here you can get the possible values, and you can get any, so you can see there's lots of Scala influence in Kotlin. Here there's a when expression, so I can call it on the function if I want, and I can use the expression language in top of the strings, the string template, and also I'm calling with one. All right, so it should get 1 as a result. I can do as expression. This is pretty cool. You can create a variable, so I'm create a variable result, and then I can put the if there. And the return of this code will go to the variable, right? And here I'm returning the result variable. Here you can also do straight on functions return. So for instance, here I'm doing a when statement on the function return itself. All these kind of things you can do in Scala as well, by the way. So there's huge Scala influence here. There's this function to create int arrays, for instance, like syntactical sugar. Then I'm accessing positions, and you can do for each. And like Groovy, there's the it implicit variable where will be the current element of the loop. All right, so for example, will be 0, then position 1, then position 2, so value 1, value 2, value 3. But actually value 1 will be 3 because I'm getting, not 3, 5, right? Because I'm getting position 1 and position 2. So 0 is 1, 1 and 2, so 2 plus 3, 5, so it's 5, 2, 3. And here I'm calling the functions, so I can run and you can see it works, 5, 2, 3, all right? So that's conditionals. Now let's take a look on lambdas. So we also can do lambdas here. So these are just like syntactical sugar as well. So I can put in one line like I'm doing here a sun, and also can put the result on the same line. And this is returned in this function sun. Here I'm creating a list of items. Then I'm folding, so basically I'm doing a reduce. I want to start with 0. Then I have some accumulation logic. I'm gonna print it and I'm gonna return the result. Here there's other lambda like in Java this is called streams. So I can do fold, which is a reduce, and then the initial is elements, and then I'm gonna concatenate then here. And here is also calling reduce, which is fold, but it's starting with 1. I'm calling the times function from int, right? That will multiply the values that times. And I'm showing that, right? And here there's a bit of more of the same, but showing with a different syntax. Like I have this integer array 1 to 6, then I'm filtering all the numbers that are bigger than 0, and then reducing them as well with the for each, but the var is outside. So this is not preferable because there's side effects, but just you can see we can do it. And this is another thing that's cool. Also in Scala you can do it with implicits, similar idea. So there's this class called HTML which has a body, and then on HTML there's this nice syntax that you are saying that you receive an HTML function, and then you can call them there, right? And then you can use it like this, right? So it's pretty clear, pretty clean. In Scala you can do similar things with implicit conversions, so similar result as well, but cool. Now let's take a look on nullables. This is another interesting one. I see some groovy influence here as well. So here's a function to parse int, but I have this Elvis operator on the string and also this Elvis operator on int. So Kotlin is the other way around. By default, you cannot do nulls, and if you put the Elvis, you are allowing to do nulls, all right? And that's what happens. So here's I have a function that by default the first argument needs to be something, and the second one can be null, can be null string. Then I'm parsing both, checking for null and printing. And here you can see that if I try to do like this, the first being null, you see won't compile. Yeah, you see there's a problem here. So that's why that doesn't work. So it's interesting default being null, not null being the default. It's cool. We can see some collections now. Some working with collections. So here, creating a list, and then I can type it with generics, and it's a list of strings. So if you take a look here, you see list string, ABC, then I'm printing them, then doing some when is A, I want to print A is here, when is D, I want to print D is here. Then I'm creating a list of fruits, banana, avocado, apple, and kiwi fruit. And then there's some, like in Java we would call streams. So we are filtering, and the item itself starts with A. So Q if it will be dropped. Then we want to sort it. Then we want to map it to uppercase. So all these guys are going to be uppercase. Then I'm going to print them all. All right. In here, Kotlin allow you to do operators overriding. So we can do plus and minus, for instance. So in this case, if I do a list and an item, we're gonna add it, and if we do a minus, we're gonna do a diff and remove it. So here you can see working. So it's pretty nice. Similar to Scala as well, I need to confess. Bit different syntax. Now let's take a look on object-oriented code. So here there's a bunch of things. So you can create a class, just say class. Here I have functions. They are return void, which in Kotlin is unit. Have coordinates with x and y, and then I can use this in a function. So like properties. You can do inheritance. So you need to say that the class is open, and then you can say a class colon another class. And that's how you do inheritance. You can interface, just do interface, pretty similar to Java. And here there's some hierarchy. So there's a shape, rectangle, inheritance from shape, and polygon from shape, and then you can do overriding. Here there's an example of annotation, pretty similar to Java, how you can use annotation. Here I have a program, right? This is a cool thing to Fluent DSLs. So if you don't have a Fluent DSL in the code, you can make it Fluent. So you can use this with parameter. So you just say with P, and then it's implicit, right? So here I'm calling all the methods that P has. I can call as many methods as P has as I want. And I don't need to do p dot, p dot, p dot. So this is a cool feature. Here I'm calling the constructor, applying actually the properties here, which is also kind of a cool. Here I'm creating a class person that has name and children with a mutable list. And then this is how you define a constructor. You use the word constructor. Then I have a full and kind of a minor constructor, calling to a string. And here I'm playing with that and printing. So I can run these guys here. So you see it's all working. Cool. So that's OOP. I also have some idioms here. So Kotlin specific things, like you can create a data class, which is similar to a case class in Scala. So you have getters, setters, hash code to string copy equals. You just say data class, and the syntax is really similar to a case class. You can do this to do, some code that will be implemented, but this is on the code, so it's cool. You can create a single to object. Again, don't need to tell that's a copy of Scala. You can create like a person, a Pojo. So I'm doing here one line, printing stuff, calling methods. As you can see, I didn't define equals method here, but I therefore have it. And here I'm creating like a map. So you can use map off and you use to have the key and the value. I'm doing a for on that map. So you can see it works. This is another cool thing by lazy. So you say, don't do this unless someone call it. When someone call it, like here, then you evaluate it. So basically, you're gonna see something else before you seeing this, right? So lazy vars. Oops. This is dangerous, right? This is like Ruby. They're really copying Ruby here. So at any time you can say a type like string, and then you can say 242. This method does not exist. and now it exists. So you can get any string and call 242. All right. So in Ruby they call it method missing or something like that. So I'm here using the file system, so listing files, and also checking if not null the size, then throws an exception, and how you do a try catch. So the syntax is slightly different. So that's it. You can see it works. Okay, we're almost done. So now we're just missing one thing, that's coroutines. It's a way you can do parallel programming. It's pretty cool as well. So that's the extra library I imported on the beginning. I have import on Kotlin X coroutines. Then here on a global scope, you need to run your code on a scope, right? So here this will run non-blocking on a coroutine. Actually, I'm blocking here, not blocking, but delaying for a second, right? Then I'm sleeping and then I'm running a block of code. That's another way to run a coroutine scope. I just say run blocking, and this code is gonna run in the block, right? So I'm gonna run another coroutine here, and then I wanna print something, and then I wanna join. So I wanna wait till the child coroutine complete so I can continue. So that's a powerful programming technique for multi-threading. So it's pretty cool. Something. So I almost forgot. We can do testings as well, right? But I don't think I have it here. Oh yeah, I do. So you can do unit testing. I'm using JUnit, as you can see here. So basically very similar to Java. No big deal. So you just have less semicolons on the code, and that's it. All right. So that's it for today. I hope you guys like it. See you next time. Bye. Cheers.